In this video, we're looking at our trigonometric relations. So the first thing we're going to look at is our trigonometric ratios of complementary angles. So remember, complementary angles are just angles that when added together add up to 90 degrees. So sine and cos are complementary angles. So if you have sine A, that's the same as having cos 90 minus A. Again, same with if you had cos A, it's the same as having sine 90 minus A. And later in the video, we're going to go through some of the examples to show you how that works. Another really important part is our exact trigonometric values for our 30, 45, and 60 degrees. So on your screen, you can see two triangles. These triangles are very important. Later, when you do Stage 6 Mathematics in New South Wales, these triangles are given to you on your formula sheet. So you don't need to memorize them. It's good to know them, but you don't need to memorize them. So we use these to find out our exact values. So how this works is like whenever we're normally finding angles, we have sine 30. So if I'm looking for which one of my triangles has 30 degrees, well, it's this one over here. So I'm going to be focusing on the right triangle. So sine, remember, is opposite over hypotenuse. Remember, so, ka, toa. So sine 30 is going to be opposite over hypotenuse, so 1 over 2. So I'll do it in a different color, 1 over 2. If I did sine 45, well, over on the left triangle, we have 45 here, so I can use that angle. Again, opposite over hypotenuse, which my hypotenuse is over here, so 1 over root 2. So you can continue to do this to fill these out. So this becomes root 3 over 2. Cos down here, root 3 over 2. 1 over root 2. 1 over 2. 1 over root 3. Let's put that 3 in there. 1 and root 3. Alright, so now that we've done that, anytime we get given sine 30, for example, so over here sine 30, that's the equivalent of having 1 over 2. And we use this later on, and I'll show you in an example down below how we actually do this. So, find the value of the pronumeral. So here we know that sine A equals cos 90 minus A. So, if we know that we have sine 47, all we need to do is replace all our A's with 47. So over here, we're going to get 90 minus 47. So that means that sine 47 is the same as having cos 43. Alright, so all you're doing is replacing that A with what it was. And the same works the other way if we had cos this time. So here we have find the exact value of the pronumeral. So this is that table we were talking about just before. Again, like all of these type of trigonometric questions, we should always label the sides. So what I'm going to do is we're looking at this angle, and that forms a straight line, so that's my opposite side, and then we have our hypotenuse here. As always, if we have so, ka, toa, which one of these has our O and our H? Well, it's this, so I know I'm using sine. So I can start filling it out like normal. Sine theta equals O over H. So sine 30 equals K over 16. And again, like always, we want the K to be our subject, so we need to get rid of this divided by 16. And we do that by multiplying everything by 16. So what we get down here is 16 sine 30 equals K. Now the problem with this is that the question specifically said we want it in exact form. Now sine 30 is one of our special degrees. So if I go back up to my table up here, if I'm looking for sine 30, I'm looking at this here, this box. It's where sine and 30 meet. So 1 over 2. So I go down here to where I say sine 30, and I'm going to just write the little note over here, sine 30 equals 1 over 2. So what that means is I can change my sine 30. So I can change this to 1 over 2. So 16 times 1 over 2. And that equals 8. It's half of it. So it's important to know that's what you need to do if we're talking about exact values. Now again, exact values only exist when you have sine 30, or sorry, not sine 30, sine cos or tan 30, sine cos or tan 45, sine cos tan 60. It has to be one of those 3 degrees. All right, 30, 45, 60. Doesn't work if you don't have them.